how actually happen when your code get compiled. So is there anyone knows about what are the phases they have to use to translate your code into one form to another form? Any idea? Hello? Hello?
Yes, sir.
So can you tell me which are the phases actually the compiler compile your code and translate the high level language to the machine code. So what are the pages you have to know and how to process that?
Sir, lexical analysis.
Okay, lexical analysis. Then next, the only lexical analysis is the steps that converted your high level language to the machine code. Okay, fine. So no issue. The compiler operate the various phases that each phase translate the source code from one respective representation to the another representation. Means the each phase they have the some input and output, right? So whenever you write a C program, it translates into the machine code. There are total 6 phases. The compiler compile your code, and then finally they have generated the machine code. Okay. So what are that 6 stages they have to use to compile their code? The first step is the lexical analysis. So what is the lexical analysis? We have seen in a brief next couple of minutes. Then second phase is syntax analysis. So they have verified your syntax that whatever the syntax you written. So that we required some grammars that you have already studied in TCS. So we'll discuss that phase as well in detail. Then semantic analysis that they have to relate some semantics about the your variables or the keywords that they have to define, and according to that they have to throw the errors or the generate the symbol tables and in many more in compiling phase. Now once the semantic analysis done, that is translated into the intermediate code generator that you have to see like if you know about the objdump command, right? So you need to be generate the source file .so and then you can .o file object file you can read the what is actually they have translated the machine level language, right? The intermediate code. Then after that they have to apply the some code optimization. Okay, so that code optimization like that if you have used a is equal to a plus 1, that optimization should be the a plus plus, means that one increment the number or the whatever the variable you have assigned the increment uh, incrementation operation or the arithmetic operation for that. And last phase is the code generation phase. So in between that 6 stage means whatever the 5 stages or 6 stages, okay, so that they have to work and they link to the your symbol table and error handling uh, mechanism. So whenever you write something wrong, so your compiler throw the error at the time of compilation, right? Is a runtime error or a compilation error. Okay, compilation time and runtime error. So some of the errors are throwing in the runtime that whenever your code get executed in your memory. Okay. So is there any question? So you basically there are the six steps of the operation for the translating the high level language to the machine code language. Okay, in the compiler. Okay. So now let's discuss the first phase that the lexical analysis. So what the lexical analysis does? So lexical analysis is just use the first phase of your compiler. It's a canon. So what happens whenever you pass some code? So it tokenize that particular code, scan the source code, and it generated the tokens. Okay, so it this this scanner is read your input left to right. Okay, character by character, and group those character into the tokens. That tokens used for the next phase input. Okay, so this character stream for the source code or the source program is grouped into meaningful sequence that they have to identify the tokens. Means let's say if you write the syntax like if function bracket inside you have to some define the condition, right? So that condition, that particular string, it stream of character, right? Tokens. That whatever the tokens pattern you have to identify. Okay, what are the tokens you have to define? Let's say if is a keyword, right? Then opening bracket is another keyword, another token. Then variables, that the identifier, right? Then again the use as the operator that you have to perform the operation like greater than, less than, equal to, whatever the logical arithmetic operations you have performing in that particular condition. And then again the identifier and then bracket as another token. And these kind of tokens, the lexical analysis scan by character by character according to use whatever the patterns you have to identify from that particular string of tokens it generated, and it assigned some unique number that has defined for that each token. That next page they have to identify this particular token as the number. Okay. For example, so let's say you have to define the x is equal to y plus 10. Okay. So now in this case, that as I said, in previous example, if statement, right? Now let's discuss the this x is equal to a y plus 10. So it's example. What are the identifier? What are the operators and what are the numbers that you need to define in your lex file? Means whatever the scanner process that token, they have to some program, right? The scanner itself has a program to translate into the another program. Okay, it auto generated the codes. So we need to identify the tokens. So X is a identifier, right? So that is a the case. The equal to is a operator, like as an assignment operator. Y is another identifier. Then plus is the additional operator. So these are the tokens you have to define in your lex file, means whatever the scanner, lex file, or the lexer, or the flex that you have to use inside the compiler, that they have to assign the some value with that. Okay. So are you understand the what lexical analysis means and how they actually process that? So in this case, that the whatever the tokens you have to generate it in the legs, okay, that corresponding ticket into the symbol table. So they are all collection into the symbol table and pass that to the next page. So you already, I think, working on the some assignment or the project that the sir has given to you, like simulation of your compiler or the also assembler, right? So that you have to implement a macro that the one your code get translated into machine code to actual executable. So you define the instruction set, then translate into the you generator symbol table, macro table, right? So if not, then I don't know. So I will ask to sir to give on to you. To you have to make practices for the understanding the in deep about the system. Uh, okay. Got it. Is there any question? Okay. So just for the point. So in this particular phase, there is a primary function that means the main primary function. So what is identifying the lexical unit that in the source code is the first one. Second, classify the lexical unit into the classes like constants, reverse keywords, and enter into the different table. It will ignore the comments into your source program. Okay. And third one, that the third primary function, that identify token, which is not in the part of your language. So that you need to be write a extra rule for that, and then they have to identify that that is not associated with your language. Okay, so these are the primary functions that lexical analysis do in their work. Okay, so now come to the next phase, that second phase, the once the your token get generated. Okay, now what happened the next? So we have generated the symbol table, we weaponized our source code. So what happened next? So next that they have to syntactic analysis. They did that whatever token you have generated, okay, all the discovering the structure in your code. Okay, so whatever the syntax that you have written, okay, it about discovering the structure of your code, what the code has. Okay, it determined whether or not the text has the following exact format they have to define. Okay, some set of rules. Okay, so in the main aim of the phase is the make sure that your source code was written by the programming is correct or not. So this is the main concern for this particular syntax analysis. Means whenever you miss some syntax, you get the error in your compilation or runtime, right? So let's say you missing the semicolon whenever you write a C program, so it throw semicolon missing as particular access line, right? So that is a syntax they have to check is it correct or not according to their grammar. Okay. So syntax analysis is a based on the rule based on the specific programming language by constructing the phases parse tree. Okay, that helps to whatever token you have generated from the previous stage. Okay, so it means that it generated the your parse tree, that is a travel, and identify or verify that particular sequence of tokens you have generated, and according to the rule they are defining inside the syntax analysis is correct or not, and according they generate the event that whatever the next says that the semantic associated with that. Okay, and whenever they have parsing and doing that, so it determine the structure of source language or the grammar or syntax language, that whatever the language you have to you choose for the compilation. Okay, so here is a list of the tasks they performing in this particular page. There are four different tasks performing. So like obtaining the tokens from the lexical analysis. Okay, so check if the expression is the syntactically correct or not. So whatever expression you have defined, that is a rule-based uh, check. They have to check that the particular statement is correct or not. Then report all the syntax errors that they have find into your program, and construct the hierarchy of structures, which is the known as a parse tree. Means it generates the parse tree as a final output to verify your all the tokens and syntax. Okay, example. So you already identify the expression and numbers, right? So in previous example, we have to see x is equal to y plus 10, right? This is a statement. Now consider that how the parts we generated for that. So let's the this expression like we have to take another example, a plus b star c. So which are the operators has a higher precedence in this statement? So a plus b means in the bracket star c. So where is your root and which is your root in this particular statement? What is your root for the your tree whenever you generate the parse? Hello, guys, can you answer my question?
Sir, whatever inside bracket.
So what is the root? I am asking the root of the your parse tree. So statement is that bracket a plus b star c. So what is the root point that you have to start to drawing or the constructing the tree for that particular statement? You have already studied this in I think CISPRO as well. I mean, sorry, TCS as well. That the construction that parse tree for the given expression, regular expression, right? So bracket used for the grouping the statement, right? So one group is bracket and another group is after the multiplication, right? Is the star. So star is your root for your tree, right? So whatever the left hand side tree, the left hand side tree have the means bracket plus means that inside the plus, right? The operator. And then again the leaf node is considered as a left and right. And then right hand side is only C. So finally the tree is generated like that. Star is a root and left child is a plus, then they have to the A and B as a child for the plus and the star as a only two child, and then C is only the right hand side. So this is your parse tree generated for this syntax. Okay, so bracket we have to not consider here to show here in the parse tree because that is a uh, group of the constant or the expressions. Okay, got it. So this parse tree is token using the whatever tokens we have getting from the previous step. They have generated like this way. So according to the grammar, they have generating the statement and generating a parse tree to validate the your code and return the all the syntactic errors that found in this particular phase. Okay. So once the this tree is generated, so now that tree is input for the your next phase, that is a semantic analysis. Okay. So semantic analysis, what semantic analysis does? So it checks the semantic consistency of your code. Okay. So in this particular tree that they have to assign the some semantic meaning for that variable. Let's say if is a keyword, variable has a number or float or whatever the semantic they have to assign to. Okay. So whatever the symbol tree. Okay, so the syntax tree is generated along with the symbol table that they have to generate in first phase to verify the given source is semantically consistent or not. Okay, and then also check the whether code is converting into appropriate meaning, so that the whatever the means if you writing something in a garbage in your code, that doesn't mean that these languages are knowing that particular thing. So according to their rules and grammar, they have to check and verify, right? So semantic analysis will check the type matching, mismatch, incompatible operators, function call improperly argument, or undeclare the variable. This kind of all the checks in that performing into semantic analysis, right? So if you assign the let's say float for the integer or the character to the float, that time you need to be typecast that particular variables, right? So if mismatch the particular type, the semantic analysis is for the what appropriate error, and you can get to see if this particular type is wrong that we have assigned the values to that. Okay. So what are the functions of semantic analysis? This is R. So first one that it helps to store the type of information gathering and save it from the symbol table or the parse tree. So whatever the symbol table or parse tree generated by the previous step, that helps to store the type information gathering and save it into the again the symbol table or the parse tree. Then allow to perform to type checking, so whatever the type is associated with that. And in this phase that if in case the type is mismatched, there is no extract the type correction, the rule will satisfy and reserve that operator as showing the semantic error. Okay, so that you have to see the type mismatch error on your screen. Now, it collect all the type information and check if type is compatibility. with that particular data, whatever data you have to set for that particular number whenever you pass the input for the program. Now it checks that if language source permitted to operate operand or not. Means that let's say you have to assign some operator or operand equal to, and then that. And just you have to write a plus b, but the whatever the value you have returning for a plus b, that operand is not available. In that time, you are where you need to be store that value. So that is a not is correct syntax, right? So means that you need to be operand missing for that. So they need to check in this particular thing. Okay, so these are the first three phases. Okay, the semantic analysis, that is a extra thing, that means actually that whenever you see in any book also, they have generally show that 4 to 5 steps, but we have to brief to in between. So whenever the syntax analysis is, semantic analysis also is the important part, that is a hidden phase inside the compiler. So in any brief of the book, that they have to just show the 4 stage or 5 stages. Okay, and we have to discuss the first two pages. Okay, in detail. Okay, so how the tokenize the your code, and how to pass and verify your tokens using the syntax analysis. So we have just today's session that we have to discuss the in brief the pages and steps processing when your high level language is converted to the machine learning. So is there any questions till now? Okay, great. I think you don't have any question. You have understand the thing. Okay, so now the next phase, we are moving for the next phase. That is the fourth, that intermediate code generation. Okay, so what is mean by intermediate code generation? So every language, okay, so when they have to interpreter or translator or the compiler, okay, so they have generated the different phases, that some translation happens in between the one code to another code. So intermediate code generation, one of the this once the semantic analysis is phase is over, compiler generate the intermediate code, that for the target machine code. So it depend on what the machine architect do you have, it's targeted machine. Let's say if you have used 32-bit or 64-bit. Accordingly, that they have generated intermediate code. So it is a representation of the program, some abstraction of machine code. Okay, hello, machine code. Okay, so intermediate code between the higher level and machine level land. Okay, so in between. So it's not a final output for your code. It is a in between the your code and machine level, and in between that representation. So they need to be generate the targeted machine code instructions, like whatever the instruction they have defined, supported, and main functions for this. It should generate the semantic representation of your source code. Okay. So whatever the semantic representation they have written to this input for this particular phase, it should generated from their representation. Whatever the instructions are. Example, that you have to generate the object file in between of the C compilation, right? So your final output is a dot out, right? So that is your final executable. But in between they have to the .so file, .ao file, .a file. So all the different libraries and objects they have to generate it, right? And they interlink with each other, and then finally they have to generate. So it holds the value of the compute during the process of translation. It's help you to translate the intermediate code into target language. So whatever the language you have to C, C++, Java, or whatever the compiler language that you have to use. Okay. allow to use to maintain the procedure order, uh, whatever the precisions they have to set up in your in your code. They have to set up that precision order of the source language. Okay, it holds to correct number of operands of the instructions, meaning that so if you already the low level program language, so that you know about which are the binary operators and which are the unary operators, that accordingly that you have to the set up all the correct number of operand they have particular instructions like a is equal to a plus b. It means that you have to be the two operands for that particular instructions, right? Example. So, for example, let's consider that total equal to count plus rate into 5. So, this is an example of statement that we have to how to generate it, this particular statement into the intermediate code. So, first that target that the T1, okay, the steps that int into float of the 5. So it translate that particular number into the float. Then step two, okay, the T2 equal to rate E2 means it always be translate from the left to right. Okay, got it. So whenever your instruction started, so right to left that they have to translate means that first they have to your checkpoint is 5, then rate, then count plus the count, and then equal to a total. So now in this form that they have to check the next step that whatever the rate you have and whatever the output for the first steps, the translation that is stored into the T2, and then again the next instruction they have generated like T3 that count plus T2, and then final total to T3. So this is a steps they have to generate it, the instructions like each step of the semantic analysis they have to uh, parse it generate according to the your code, okay, or the expression. Got it? So now we have completed the 4 steps of the compilation. Now move for the next phase, that is the code optimization. So that is the important phase that in a compiler that they have to optimize the code. So some of the optimized algorithms that they have to implement it in each of the compiler that depend on what the optimization needs from according to the your uh, language. Okay. So in this phase, that code optimization or intermediate code generation. Okay. So this phase is remove unnecessary code of line and arrange the sequence of statements to speed up execution of your program without wasting the resources. Okay, it means so. Let's say you have to do some adding the few extra lines. Let's say not necessary. Let's say key if else statement. So there is a multiple way where you are write to if else statement, right? So it is a question single line function, or you can write the multiple line function. So what is the optimal way to execute that? So they have converting the your unnecessary code, I mean that code of line and rearrange the sequence. So they have translate that particular syntax into the optimal way and then minimize the your uh, statement and arrange the sequence of lines to do the faster execution. Okay. So the main goal of this phase is to improve the intermediate code generation. The code intermediate whatever the code is generated intermediately that generate a code that run faster and occupy the less space of the memory in your machine. Okay. So what are the primary functions that this phase do? So first, it helps to establish the trade-off between the execution and compilation. Okay. So that is the main thing that you every program you need to be do that means, run faster. Okay, the execution and get the results earlier. That the main concern that whenever you run the program, optimize it. So improve the running time of the targeting program, generating streamline of code. still in the intermediate representation. Okay, so it again it generated another intermediate representation. Okay, it not the final code. It is a just optimization phase that they have to remove the unnecessary lines of code and optimize the restructuring the your code according to the rules. So generate the that the main thing generate the streamline of code still in the intermediate representation. Removing the unreachable code and getting the right unusable variables. So those are the variables are not used. You define the unnecessary space is wasted that they have to remove that. Removing the statement uh, which is not altered from the loops. Okay, so that statement also is remove and do the optimization. Consider let's say the example. So that a is equal to int to float. Okay, so that's the value 10. Then this is a statement I have just intermediate code, whatever the code is generated, that what optimization is it, we can discuss. So this is the fourth statement. Okay, A, B, C. Let's say A is equal to into followed. Let's say 10 number. Then again B is equal to C star A, and then again D is equal to E plus B, and finally F is equal to D. So this is the fourth statement. Now this is the intermediate code generation. So what optimization performing in this particular for statement? So it can become converted into only two. So how? So B is equal to C star 10. So you don't need to be translate that, means that unnecessary A to float. So directly they have to float value. So C star A. So the first line is removed. And then again, you don't need to assign the directly intermediately that whatever the results come from E plus B. Instead of that, you directly assign that result to the F. F is equal to E plus B. So that statement is removed. That is optimized the remove the unnecessary statement and it optimized into the two. Means the line of code in previously they have generated in the intermediate code is a four line. After the optimization, it become a two line. So once that code is generated, that code should be the passed to the next phase. For the next phase is the final phase that is generated code. There's a code generation phase. It's the last and final phase of the compiler. Okay, it's take inputs from the code optimizer phase and produce the page of code or object code as a result that you have to run as a final executor. Okay, with that particular machine, target machine. The objective of this phase is allocate the storage and generate the locationable sorry relocatable machine code that you have run on your machine. Okay, so in memory, it's allow also allocate the memory of location of for the variables that they have to use in your program. Instruction in intermediate code converted into the machine instruction that whatever the architecture that they have to use for the compiling. This phase convert the optimizer or the intermediate code into a target machine language that they have to define. So target machine language is a machine code that is all the memory location and the registers are selected and allocated during the phase. So this is the final phase that they actually allocate the memory and register and run the code uh, and execute the whatever the input you have to given. So take and generate the output. Means example. So if you uh, do that, let's say A plus A is equal to B plus 60. So this is your statement. It will be the generated into the machine language, that the assembly language, like move F A use a register. Mul F is a multiplication instruction that they have to is refer the number, whatever the constant they have to define into register 2, and then add instructions R1 and R2. The R1 R2 is the register that they have to assign the value or store the value of that particular step or the variable. Okay. So you is there any question? that this is a code generation phase, is the last phase that after this code phase, your actual executive file is generated with the targeted version. Is there any question? Hello.
No, sir.
Great. So let's have some few of the points that we need to be know about in the compilation. That the thing is symbol table management and error handling routines. So all of you know about symbol table, right? The symbol table is a contain a record of each identifier with a field for the attributes of that particular identifier. The components that make easier to compiler to search their identifier record and retrieve the quickly. Means that symbol table is help to compiler. They have to search their identifiers record and whatever the semantic meanings associated with that in the symbol table. So they retrieve quickly. Symbol table also helps you for the scope management, how the your variables management inside the particular variables, what is the scope and global scope or the function flow, that how you can manage that memory, the some shared memory or the uh, extra memory that we have to use in the into execution time. Symbol table and error handling interact with all the phases that symbol table update correspondingly. Means this symbol table update every time that whenever the compile move from the next phases. Each phases they have to interact that particular table. With the whatever the meaningful information they have to show, they have to retrieve and use in each and every pages in the compilation. So this is a symbol table management. Now let's move for the next, that the error handling routine. That in the compiler process, error is the many occurs all the time and all the phases that what. So in first lexical analysis is wrongly spell the tokens. This is the error routine they have to use. Now semantic analysis, that they're missing the parentheses or the uh, some wrong things you have to return, that syntax analysis, that they have to be identified the syntax analysis. Next, intermediate code generation, that is a mismatch the operand for the operators. Let's say ki add have the two operand instructions that, and you just mentioned the one. It is not a unary, it's a binary operator that they have to throw the errors. Now, code optimization, that's when the thing, when the statement is not reachable, that time they have to be throw the errors. Okay. Next, that the code generator, when the memory is full or the proper register are not allocated, they have to throw the error of the code generation part. Symbol table, that the error of multiple declaration identifier. That symbol table is throw the errors, that if you have the already declare the identifier and you again declare that time they have to throw the errors. So these are the some routines they have to use in compiler each and page that throwing the errors. Most common errors are individual character sequence and scanning, invalid token sequence in type, then scope errors, and parsing the semantic analysis. The associate meaning is not associated that particular keyword or the functions. The error may be encountered in any of the above phase that we have already discussed. That after the finding the errors, the phase need to be deal with the errors to continue with the compilation process. So you need to fix that errors and then you can rerun the programs. Right. So those errors need to be reported to the error handler, which is handling in your to perform the compilation phase. And generally, error reported from the message that you have to see in your screen when you compilation run the compilation command. Okay, so now today's session we have to uh, discuss these different phases of compiler. introduction to how to compile session is happen, right? The in your program. So is there any question? Hello.
No, sir.
No, sir.
Okay, fine. Great. So we wind up the today's session. So today's session we have whatever the discussion we have. So I'll share with the notes with you. Okay. So we will meet on the Wednesday, right? Next session is a Wednesday evening. Okay. So we have to take in detail the first phase of the compiler. Okay. That is a lexical analysis in that lecture, and then take one practical tool that we have to use for doing the tokenizing, scanning our program. Okay. Okay. Fine. Then we can stop here. Is there any question or the issues that you have to in today's session? So you can communicate with me, or you can we have the some communication channel that you can ask, or either you can post on the group. Okay, or message. So we'll solve your problem. Fine. Okay, then thanks for attending the session. So we will meet on the Wednesday. Okay, thank you.
Thank you, sir.
Thank you, sir.
Have a great evening.